Let us have a discussion on HTLS conductors. The full form of HTLS is High Temperature Low Sag. HTLS conductors are advanced overhead transmission conductors designed to carry significantly higher current at higher temperatures. The range of maximum operating temperature is from 150 degrees Celsius to 250 degrees Celsius. That means the sag of an HTLS conductor remains within limit in this temperature range. The current carrying capacity of a conventional conductor like ACSR is limited by thermal expansion. Actually, when current increases, the temperature of the conductor increases. Therefore, the steel core as well as the aluminum conductor strands also expand. The main drawback of the conventional ACSR conductor is its temperature limit. You cannot transmit electricity through the conventional transmission conductor beyond the temperature of 75 degrees centigrade. Even nowadays, some manufacturers are manufacturing ACSR conductors with a temperature limit of 85 degrees centigrade. But if you increase the current through this conductor beyond its limit, the temperature will increase beyond 75 degrees centigrade or 85 degrees centigrade, and the sag of the conductor will increase, which reduces the ground clearance of the overhead conductor, which is not allowed. So to maintain the sag, you need to maintain the temperature of the conductor. And to maintain the temperature of the conductor, you have to limit the current carrying capacity of the conductor, because current is the main cause of the temperature in the conductor. The condition is such that the demand for power has increased abruptly over the last few decades. So we need to increase the capacity for the transmission of electrical power from one point to another. But nowadays, the land problem and ROW or right-of-way problem have also increased abruptly. So it is very difficult or next to impossible to construct extra transmission lines parallel to the existing one. This is the main challenge of transmitting electricity. In strung ACSR conductors, both the steel core and the aluminum conductor share the mechanical load. At high current, that is, at high temperature, due to the different coefficients of expansion, the steel core elongates less than the aluminum conductor. Therefore, the aluminum conductor releases its mechanical load to the steel core. Due to this higher excessive mechanical load, the steel core gets elongated permanently day after day. So to maintain the sag, the current has to be limited in ACSR conductors to control the temperature rise. Although the current can be increased in a conductor, this is only possible if the sag is maintained at the higher temperature. To maintain the sag, HTLS conductors use specialized cores such as invar steel, carbon fiber, or carbon composite materials, which have minimal thermal elongation. At the same time, to limit the thermal expansion of aluminum strands, annealed aluminum is used instead of hard-drawn aluminum. Now, come to the constructional details of an HTLS conductor. There are 5 major changes we have made in a normal conductor to make it an HTLS conductor. Number 1, we have to replace the steel core of an ACSR conductor with carbon composite, or carbon fiber, or invar steel core, because these materials have very low coefficient of expansion with temperature. Therefore, due to temperature variation in the conductor, these cores will not change their length, so the tension will be the same. Second one is, we have replaced the hard-drawn aluminum of the conductor with annealed aluminum. This is because, due to the annealing process, the expansion due to temperature in aluminum is reduced. This means, by the annealing process, we can reduce the temperature coefficient of expansion of aluminum itself. So even at high temperature, aluminum will not expand like hard-drawn aluminum. So the expansion in aluminum can also be reduced. One major difference between an ACSR conductor and an HTLS conductor is that in an ACSR conductor, the entire mechanical load of the strand conductor is shared by its steel core and the aluminum part of the conductor, but in an HTLS conductor, the entire mechanical load is carried by only its core, not by the aluminum part of the conductor, because here aluminum is annealed aluminum, and annealed aluminum is very soft, so it can almost not carry any mechanical load. We use a galvanic protection cover over the carbon composite core or other HTLS cores to prevent the galvanic action between aluminum and the core material. In an ACSR conductor, all the steel strands are galvanized, so there is no need to provide any extra galvanic protection layer on the core. Zinc on the steel is the galvanic coating of the core of an ACSR conductor. But in the case of an HTLS conductor, we have to provide an extra galvanic protection cover. This is generally made of fiberglass material on the surface of the central core of the conductor. In some designs, we also change the shape of the strands of aluminum conductor. Instead of using circular cross-sectional aluminum strands, we use rectangular or trapezium-shaped conductor strands to fill the gap between strands. By this way, we increase the current carrying capacity of the conductor. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you never miss an update. Got questions or want us to cover a specific topic next? Drop a comment below. We'd love to hear from you. Thanks for watching, and see you in the next video.